Guys, so continuing on factoring, we're looking at factoring ax squared plus bx plus c, so when the leading coefficient is not 1. I'm going to skip straight to the examples. So one method, if the leading coefficient is not 1, is if there is a GCF, then you factor it. That's a big if, because you might not be able to factor something from every term. But since this is an example, then you can. So let's do that. We can factor, what can we factor from 5x squared, 15x, and 10? In this case, we can factor 5. Right, so we do that. So after I factor 5, what do I have left over? X squared plus 3x plus 2. And if you're confused on how we get that, we just literally divide each of these terms by 5. So 5x squared divided by 5 makes x squared. 15x divided by 5 makes 3x. And 10 divided by 5 is 2. If you're still confused, then you could think about it like, oh, 5 times x squared brings us back. 5 times 3x brings us back. And 5 times 2 brings us back. Either way, you start off by factoring a 5. Or if it's, if you could factor out anything, then that's what you factor. But in this case, we're going to factor a 5. And then we have this, which looks a lot more similar to the last section. And it's a lot easier for us to deal with, right? It's like, oh, what adds up to 3 and multiplies to 2? And in this case, that's 1 and 2. So 5 times x plus 1 times x plus 2 gives us the factored form of 5x squared plus 15x plus 10. If you don't know why x squared plus 3x plus 2 turns into x plus 1 times x plus 2, you should probably go back and watch the video on the last section. But a reminder is that 1 plus 2 adds up to the middle term, 3, and multiplies 1 times 2 to the last term, c. So that's factoring a GCF. If you can, then do it. But when there is no GCF, consider the possible factors of a and c. So let's, as a reminder, a, b, and c are just the coefficients. So a is 4, b is 13, sorry, c is the constant. A is 3, b is -7, and c is 2. So consider when there is no GCF, like there isn't here, 4, 13, and 3, I can't divide all of them by 2 or 3 or 4. Then I have to consider the possible factors of a and c. So a is 4 and c is 12. So I'm going to go ahead and multiply those. So ac is equal to 12. And then I have to think about the factors of AC that add up to 13. So this one's going to be pretty easy, 1 and 12. Right? I could stop right there because it adds up to 13. But if it was something, if the middle term was not 13, then I would have to keep going to be like 2 and 6, 3 and 4, -1, -12, and so on and so forth, right? But since it neatly adds up to 13, then I could just stop right here. And I'm going to rewrite this problem using these two terms. So 4x squared plus 12x plus 1x, which is the same thing as x, plus 3, right? So I'm actually just going to erase that one because it's unnecessary. And all I've done so far is I've rewritten this problem. 13x, I know, is really just 12x plus x. And then I'm going to factor by grouping. So that's when I split up the first group and the second group, and I treat them separately. So 4x squared plus 12x, what can I factor from that? What can I factor from 4 and 12? Well, 4. And then what can I factor from x squared and x? X. So if you're confused, it's the same way we factored out the 5 from everything in here. I just look at what I can factor out, and I do that. So where do I get x plus 3 from? Well, just like here, 4x times x makes 4x squared, and 4x times 3 makes 12x. Or if you want to go the other way, 4x squared divided by 4x is x, and 12x divided by 4x is 3. Either way. So that's that. And then we're going to move on to our second group. So what can I factor from x and 3? The only common factor they have is 1. So I'm going to write 1. So 1 times x is x, and 1 times 3 is 3. What you'll notice is that these parentheses are always the same. If they are not the same, then you're either doing something wrong or you actually can't factor by grouping. So those parentheses should always be the same. And our final step is to rewrite it. X plus 3 is being multiplied by, what is it being multiplied by? Well, here it's being multiplied by 4x. And then here it's being multiplied by 1. So what I'm going to do is I'm going to say x plus 3 is being multiplied by 4x and 1 is the gist of it. And then if you want to double check your answer, then you could just multiply using a table or FOIL, and you'll get back to this. So now that I've done it one time, I'm going to go ahead and break it down into a series of steps. So first, you should try factoring out the GCF, right? If you can, then do that. But if not, then it gets a little more complicated. And I'm going to break down those steps for when it gets complicated. Identify factors of AC that add up to B. So AC means multiply the leading coefficient 4 with the constant at the end, 3. Or in this problem, which I will do next, it will be 3 times 2. That add up to B. So factors of 12 that add up to 13. The next thing you'll do is, or the next thing I did, was rewrite the problem using factors as middle terms, using the factors that we just found as middle terms. So I said 1 and 12. I probably should have put 1 and then 12, but it doesn't really matter. You'll get the same answer no matter what. So I put 12 and 1, so 4x squared plus 12x plus x. So the 12 and 1 is right there to replace b, the middle term. And then lastly, we have factor by grouping. First two, last two. Right. So I'll walk you through another problem. This is the second example. Using these steps. So identify factors of AC that add up to B. So 3 and 2. 3 times 2 is 6. What are some factors of 6? 1 and 6. 2 and 3. Do either of these add up to -7? Oh, well, don't forget your negatives. -1 times -6 multiplies to 6 and adds up to -7. Oh, we found one that works. We did that part. Or actually, I'll just put a check mark. Check mark, we did that part. Rewrite the problem using factors as middle terms. So I'm going to use these factors and put them in the middle to replace -7x. So what does that look like? 3x squared, and instead of -7x, I'm going to say minus x minus 6x plus 2. So I just took these two and I wrote them in the middle. And it's fair because they add up to -7. Check mark. Last part, factor by grouping. First two, last two. Oh, I should erase that other part. Okay. So let's look at the first two. What can I factor from 3x squared and -x? Can I divide them both by 3? No. I can only divide them both by x. So I factor in x. So 3x minus 1. Then I'm going to look at my second set and think, okay, what can I factor from -6x plus 2? Now my first instinct is to factor a 2. But then I think about what's in the parentheses, and I'll be like, oh, well, 2 times what gives me negative 6x? And I would have to have a negative 3x here. But since that would mean the parentheses are not the same, then I don't want to do that. And so what I will factor is a negative 2. So the reason I factor a negative 2 is so that I can write 3x minus 1. These parentheses have to be identical. 3x minus 1 times x, 3x minus 1 times negative 2. If you're not multiplying this by the same thing, then you can't rewrite it the way that we do. So finally, we have 3x minus 1. What is it being multiplied by? Well, after I cross it out, I have left over. 3x minus 1 is being multiplied by x, and it's also being multiplied by negative 2. So that's how you factor an ax squared plus bx plus c type problem. So like if you can't factor out a GCF right away, then you have to do this, right? So I would definitely copy this down. Kind of formulaic, but definitely works. So I would go for it. If you have any questions or you're confused, let me know, or ask some questions, ask classmates, whatever.